Okay. So, hi Sarah, hey Dave.
Sure.
So first of all, happy Holi to everybody. I don't know who all celebrated it yesterday, who all are celebrating it today. So, okay, so there is a new child in the class, no, new kid in the class. That's what I call you all, right? So, with the name Deepak Kumar. Beta, can you go ahead and tell your name?
Yeah, Deepak Kumar is my dad's name.
Yes. And your name is?
Deep.
Deep. Okay, wonderful. So going forward, when you join, see if you can join with your name. So that way, I will not keep on confusing everybody with a different name. Okay.
Yeah, I got it.
Okay. All right. So welcome to the class, Deep. So let me do a quick roll call and we'll get started. So we have Deep, we have Dev, we have Dhanushri, we have Praneeth, we have two Chris, and we have Neil, Sarah, Rehan, and Sunarka. So one more time, happy Holi everybody. We'll get started. So we are in unit 4 actually, where we are learning advanced math. The unit name is called Foundation Advanced Math, and as part of that, today we are going to talk about, or today we'll be focusing more on the word problems related to polynomials and quadratic equations. Okay, and in previous classes we have learned how to solve quadratic equations. Most of you know it. Some of you who would not be able to recall, when we solve the problems, will be able to recall that as we practice more. And remember one thing, in the class whatever we do, that is only to learn the concepts, and for you guys to become an expert in those topics, you would certainly need to do a lot of practice. So what we'll do today is we'll look at some of the interesting word problems that I picked up from Khan Academy itself while I was kind of preparing for the class, and we'll try solving those problems in the class today, applying the concepts that we know or that we have learned in the past. And if anybody is getting stuck at any point in time, please feel free to stop me, and it'll be a very engaging class like I always try. So if there's something that I'm asking you guys to solve, give it a shot. I mean, you may or may not be able to solve it in the first go, but not trying is not acceptable. I expect you all to participate, practice, try solving it, and when you get stuck, that is what gives me input to look into finding ways to explain things to you guys. Alright, so are we good to get started? Okay, and so I'm assuming everybody would be able to recall when we talk about solving any quadratic equation. If anybody says solve a quadratic equation to find out the value of x, let's say if my equation is like x squared minus 16x plus 64 equals 0, solve it for x. The only thing that we always look at is converting this into factor form. I'm just making it up, okay? I'm not solving it. So if I say this becomes x minus 8 into x plus 8, I'm just making it up, okay? This is completely wrong, I know it. But ultimately our goal is to convert this into factor form, get an equivalent of this equation, convert this into factor form or factored form, and then once you get to this situation, you will say, okay, fine, that means either this equals 0 or this equals 0, right? If you have 2 into 0, that will be 0, or 0 into 2, that will be 0. So basically, one of the two is 0, that's how your end result is 0. So that's what we are trying to get to by trying to convert this into factored form, right? So any quadratic equation that you try solving, and we have learned 3 different methods for doing it. One is by relating that with the generic formulas that we know, a plus b whole square, a minus b whole square, a square minus b square, or second method is by splitting that into looking at the a and c and the b part, and see how do you get a into c to split into, how do you get A into C and use that information to break this into two parts, and then that helps you get to the factored form. Anyways, I'm not going to repeat that, but when we solve it, we'll come across that. And the third method is obviously the quadratic formula, the quadratic equation that straight away tells you that if you have a standard quadratic equation, how do you get two possible values of x, which is nothing but if you have quadratic equation like this, then that tells you that you will have two possible solutions of x, which equals minus b plus minus b square minus 4ac by 2a. Okay, one is with the plus value, one is with the negative value. Okay, so and you guys all know it. Some of you who would want to recall, we will recall it when we solve the problems. Okay, is that a good starting point, everybody?
Yes, sir.
Okay, so all right, let's get started. So what I will do is I will use my phone quite a lot today just to find out the questions. And before we start, for deep, this is your first class, so that gives me an opportunity to talk about one magical formula that we all have learned, or that I keep on emphasizing on, which becomes like a silver bullet for solving any and every. Okay. Any and every mathematical problem that we come across. I call it TRAN. T stands for trust. Every problem that you come across, don't give up. Always believe in yourself that, okay, if there's anybody in the world who can solve it, that is me. That has to be part of your personality, your character, whatever you call it. And then comes R. R stands for read, meaning if you have a question at hand, read it once, twice, 3 times, and that will be practice today, okay, when you're trying to solve it. When you read the question a couple of times, you will see that the question becomes 2 times easier or 3 times easier. So where we go wrong is, we don't put much focus on reading the question enough to get all the information that it has. Once you have read the question enough and you are sure that you know each and everything that has been asked in the question, then you go to A. And that is when this A stands for analysis, meaning you are putting your brain to work. You have started making the blueprint of how you are going to solve it. What you know versus what you don't know. What is the formula that you can apply? What is the best method for solving a problem? And you will see that in action, okay? So trust yourself, read the question enough, then you analyze. Once you have done enough analysis, meaning you have thought, okay, this is the question, this is what it is asking, I know this formula, I can apply this formula, this is how I'm going to solve it. You have made your blueprint. And then comes N. N stands for Nike. What does Nike say? Just do it. So doing or solving the problem comes as the last step. Where we go wrong as a student is always when you try to solve the problem immediately. As soon as you got the question, you jump onto it and you start solving it. That is where the possibility of going wrong is more. And I know everybody in this class except Deep would have gotten tired of me by hearing this so many times, but trust me, that's the way to go. And if every time I repeat myself, I'm having a hope or belief that you guys are kind of getting back to the basics, making sure that you don't try solving a problem without doing your reading, without doing your analysis, and then you try doing it. Okay? So with that being said, let's apply the same TRAN method for solving all the problems that I sent in the group. Okay? So let me pick up the first problem. And you will see that I'm not teaching you guys anything new. This is something where you're applying the concepts to solve it without getting stressed out by the problem itself. Let me read it for you guys first. The question says, Rodrigo watches a helicopter take off from a platform. The height of the helicopter in meters above the ground, T minutes after takeoff is modeled by. So again, I'm reading a question for you guys one more time. Rodrigo watches a helicopter take off from a platform. So there's a helicopter. Even if this doesn't look like a helicopter, you have to believe me. He is watching a helicopter take off from the ground. So this is the ground and the helicopter is here. The height of the helicopter in meters above the ground, T minutes after takeoff. So let's say after 1 minute it is here, after 2 minutes it's here, after 3 minutes here. So they have given a generic formulas which says height of the helicopter after t minutes from the ground is modeled by this equation, which is minus 3t square plus 24t plus 30 plus 60. Okay. So this is the model that is given. Then says Rodriguez wants to know when the helicopter will land on the ground. So you would have noticed that I have read the question so many times. Let me unlock you guys. You guys got locked out. This says that, since I read the question a couple of times, this is what I understood. That okay, and somebody named Rodrigo is watching the helicopter take off from the ground. And this is the model that is given, saying that after t minutes post takeoff, this will be the height of the helicopter. Okay. So after 1 minute it goes somewhere, after 2 minutes it goes somewhere, after 3 minutes it goes somewhere, and after t minutes, whatever be the value of t, this model gives the path or how much the height of the helicopter would be. This is coming from this model. So the question here is, after how many minutes the helicopter will come back to the ground. So after having heard this question so many times from me, I want to hear from you guys what would be your thought process. What is the interpretation from this question, sir? Don't try solving it. What is that you interpreted from this question? Anybody? And try teaching that to your teacher, okay? Imagine I am a second grader and then you're trying to explain this to me. Yes, Pranit.
So with this equation, we can see it's a quadratic equation, meaning there is a possibility of two different x values or roots, meaning where the helicopter touches the ground. We know the first one is when it's starting to lift off. Second one would be when it touches down, so we could find the x values and we could see which one, and that would give us the x, and we can plug that in, finding at what time the helicopter touches back down.
Okay. So that is one explanation. Pranit, you kind of explained that pretty well, but one mistake you made was you assumed that I know quadratic equation being a second grader. Okay. Let's see who else can explain this in a even simpler way. But Pranit, no disagreement with respect to the way you explained it. Anybody else? Dave, Sunarkar, Neil, Sarah, Rehan, anybody? Nanushri? You guys have to assume that I'm a second grader, okay? That's the situation you're dealing with. Or Deep. I know this is your first class. You might be thinking what this old man is explaining and why he is forcing all the kids. But I'm kind of trying to build that approach for you guys. That's why I'm asking this question. Anything that is simple is beautiful, okay? So I'm just trying to keep it simple for you guys. Okay, so let me not get you guys stressed out. See here, by reading the question a couple of times, how would a second grader read this? That, okay, fine, there's a helicopter. Somebody is monitoring the helicopter's movement, and after every minute passing by, the helicopter moves in a certain direction. And this is the formula. Okay, the second grader would not understand this formula, but says, okay, fine, after t minutes, okay, when I put a value of 1, ti equal to 1, I'll get some value that will tell me how high the helicopter has flown so far. After 2 minutes, I'll put the value of t equals to 2, and it would have gone to a certain height in 2 minutes, and I can go on. Now the question says, after how many minutes the helicopter will touch the ground again, right? And when you touch the ground, what does it mean? Meaning the height will become 0. So there is a situation that we have to figure out when that is going to come, that we are going to come across, when height becomes 0. And we still don't know how many minutes. Okay, so that means this plus 24t plus 60. This whole value after a certain minute, height will become 0, meaning helicopter goes up and maybe because of the fuel or because the pilot got tired, it touches down. And again following this formula. Okay. So we have to find out a time when the height becomes 0, meaning it touches the ground. That's the objective of this one. So now I'm no more a second grader, okay? I changed my plan. So now, based on whatever we understood from the question, this is what we are trying to find out. Now, when we look at this as an equation, say, okay, fine. Height is becoming 0 when it's touching the ground, and we don't know what is the value of t. So let's find it out. What are the possibilities? So now I have a quadratic equation at hand which says minus 3t squared plus 24t plus 60 equals 0, or let's knock off the minus here. Let's take minus common out. It becomes 3t squared minus 24t minus 60 equals 0, or I can multiply this side by minus and multiply this side by minus. So this becomes 3t squared minus 24t minus 60. Minus into minus becomes plus, so that's why I just took it out. And 0 into minus doesn't make any difference. Or if you say minus 1, whatever be the case, it remains 0. So this is the quadratic equation that we're trying to solve. So all that story that I was giving you guys with the question ultimately translates into this. And as long as we are able to find out the value of t from this quadratic equation, we should be fine. Yeah? Are you guys with me so far? So what I have done is, when I read the question a couple of times, I forced you guys to read the question a couple of times, I finished the t, this t is always with me. I mean, I don't have the option of not trusting myself when I'm daring to teach you guys, right? So t is always the option with me. I mean, it has to be a mandate, not an option for me, or even if I'm a student. And then I went to R. When I read the question a couple of times, you guys got tired of hearing this question again and again. But then what that led to is, nobody had any doubt about the question, that what exactly we're trying to find out. And then I did the analysis. That is when I said, okay, when I read the question a couple of times, say, okay, fine, this was the equation, and says when it touches the ground, meaning my height becomes 0. So in this equation, this part will become 0. That is what the analysis was. So that means this equals 0. So if I want to solve it for t, I will know the time. So that was all the analysis that we had. Believe me, I have not done any calculation so far. I have just rewritten this equation in a form that sounds more familiar to us. Yeah. And then comes Nike. Just do it. Now you have an equation at hand. Just do it. You know that if I just solve it for t, I'm done. Yeah. And when we are in a situation like this, if we know the quadratic formula by ourselves, then we know that if I have a quadratic equation like this, or we know that if I'm trying to solve it for x, it becomes minus b plus minus b squared minus 4ac by 2a. So here, if you compare this with the equivalent of the quadratic equation, what is your a? Your a equals 3, b equals minus 24, this one, and c equals minus 60. So I can simply put that in this formula and I should be able to solve it. So I mean, here we are not trying to solve it for x, we are trying to solve it for t. And we know the value of b, we know the value of a, and we know the value of c also. So we will just substitute that value here. So minus b is minus 24, so minus of minus 24, plus minus b squared minus 4ac, b squared minus 4ac, b squared 24 is squared minus 4ac, so 4 into 3 into c, c is again minus 60. So divide by 2a, 2 into a is 3. So here this became 24 plus minus, here 24 is squared, so this and this becomes minus into minus plus, so I just change this one, So 4 into 3 into 60. So this is 4 into 3 is 12. Okay, so it becomes 24 into 24 plus 4 into 3 12, and I'll borrow 2 from this guy. So this becomes 24 into 30 by 2a, which is 6. So 24 plus minus here I'll take 24 out, so 30 plus 4, 34. Okay, so whatever the value be, it becomes 24 into 24 plus 30 by 6. And then I'll leave it for you guys to calculate and find it out. So if you look at this whole problem, right, it was a typical word problem where it was saying that, okay, fine, we have somebody watching a helicopter take off, and that takeoff or the height of the helicopter after a certain time is based on this model. So the question is, when will the helicopter touch the ground again? When it touches the ground, the height becomes 0. So it's more like a projectile path that you are probably going to see with the helicopter based on this model. So when the height becomes 0, then you have a quadratic equation to solve for. And when you convert this to quadratic equation, when you look at this quadratic equation and you put 0, then this is your quadratic equation that you have at hand. And you know you can apply quadratic formula, you can do factored form or whatever to solve for t. And here you will get two values of t, one with a positive, one with a negative. Once you solve, find out the square root of this value, or square root of 20 into 54, whatever the value is, it's still a positive value. So you are looking at 1 with 24 plus this value, square root of this value by 6, and second is 24 minus square root of this value by 6. So you have two options. So that says that there are two times, if this model is to be believed, there are two times when the helicopter will touch the ground. Okay. So maybe the helicopter is flying like this. It starts from here, comes here, again flies, comes back here. So that's why, apart from the starting point, it touches the ground here and here. Okay. So the pilot did not get tired, he's just having fun. Was this explanation giving you the right path to follow? Did you guys understand what I did, or I got you guys just confused? Okay, Pranit understood. Deep, this is your first class, so I'll keep on putting you on the spot just to make sure that you're able to follow what I'm doing.
That was a good explanation. I understood, yeah.
Okay. Dhanushri, Sunarka, Chris, Dave, Neil, Sarah, everybody clear?
Yes, sir.
Okay. Rehan, clear? All right. So let's go to the next problem. And again, you will see that I'll keep on doing the repeat telecast of what I did with the tram, right? So we'll keep on using tram. If you don't believe in memorizing things, I don't believe in memorizing for sure. And what I don't practice, I will never preach. So if you don't want to memorize this, you don't have to memorize this. This is more of a practice, more of a behavior. I'm saying, okay, trust. As long as we are all studying, trust is given. How did you run? Yeah? That defines your whole methodology for solving any mathematical problem. Read, analyze, and then do it. As long as you practice that approach, you will see your chances of being right is more. It might look in the beginning that you're going to spend a lot of time reading and analyzing, but no, it's not that way. When you read and analyze, you will see that when you think about a problem, you might end up figuring out a faster way of solving it. So the effort that you're putting for reading and analyzing the problem, it might help you save your time for the actual solution part. Otherwise, we do a lot of scratch work, and then finding the right solution it takes time. Let's go to the next one. This one says, again, we are going to the second question, okay? And I have a very unique problem. I see better without my glasses, okay? That's why I'm taking off my class in between. The question is, the expression 5 2 to the power t gives the number of leaves in a plant as a function of the number of weeks it was planted. What does 2 represent in this expression? And then you have multiple options. But before I look at the options, right, before we get biased with the answer, let's read the question one more time, right? The R part of it. Let it remain in the corner. I will not erase it. So I'm doing the R part of it again. Meaning I'm reading the question again. The expression 5 into 2 to the power t gives the number of leaves in a plant as a function of number of weeks since it was planted. I read 2 times. I think I am tired now. The expression 5 2 to the power t. This is the expression given. Gives the number of leaves in a tree. So you can say, okay, number of leaves. I'll put this as L. Okay, L as number of leaves. This gives the number of leaves in a plant as a function of the number of weeks since it was planted. Here, if you look at t is nothing but the number of weeks. Okay. What does 2 represent in this expression? The question is this. See, when you read this expression couple of times, the question couple of times, it says number of leaves after a certain number of weeks is a function of the number of weeks since it was planted. So t is nothing but your number of weeks since it was planted. So if I'm talking about how many leaves it had on day 0, meaning before it was planted. Meaning, I will put a value of t equal to 0. When I say L0, meaning on day 0, before the plant was actually planted. So 5 into 2 to the power 0. I am saying before it was planted because t says after it was planted, right? Number of weeks after it was planted. So I'm saying 0 is week. It says, meaning before the plant was actually planted on the ground, it was 5 into 2 to the power 0. 2 to the power 0 is nothing but 1. So when you bought the plant, before you planted it on the ground, you had 5 leaves in the plant. Okay. Now, after 1 week, it will be what? 5 into 2 to the power 1, which becomes 5 into 2. That is 10. So after 1 week, you will have 10 leaves. After 2 weeks, you will keep on putting the value of t from 1, 2, 3, 4, and you will get the number of leaves. But that is not the question. What does the question say? The question says, what does 2 represent in this expression? What does 2 represent in this equation? In this expression? So, I will let you guys stress out yourself a little bit and think. T represents the number of weeks which will determine how many leaves you will have since the plant was planted. Now, what does 2 represent? And let me read out the questions for you. Okay, you don't have to really think too much about it. It says, the option that you have as part of this question says, there were initially 2 leaves in the plant. First one says, initially there were 2 leaves in the plant. Okay, that was the first answer. Second answer says, the number of leaves is multiplied by 2 each week. The number of leaves multiplied by 2, it's multiplied by 2 each week. Okay. And the third option is, the plant was planted 2 weeks ago. Planted 2 weeks ago. So, when you read this question enough, when you looked at the options, we were doing our analysis only so far. Okay, fine. This is how many leaves we will have based on this. Okay, so after 1 week, before it was planted, it had 2.0 or 5 leaves. After 1 week, it was 5 into 2, 10. Let's say after 2 weeks, how many was there? 5 into 2 to the power 2. That will become 5 into 4, which is 10 leaves. 5 into 4, 20. My bad. I cannot be that wrong with my calculation. Okay. So before it was planted, it had 5 leaves. After 1 week, it had 10 leaves. After 2 weeks, it had 20 leaves. And when you go to 3rd week, you will see 5 into 2 to the power 3, which is 5 into 2 into 2 into 2, 8, which becomes 40. So now let's look at the options that we have here. The first option says, there were initially 2 leaves in the plant. We saw that initially, meaning before it was planted, it had 5 leaves. So first option is ruled out. This is not possible. Second one says the number of leaves is multiplied by 2 each week. And that's what we are seeing. Before it was planted, it was 5. First week became 5 into 2. Next week became 5 into 2 into 2, which is 10. Oops, my bad. 0th week, before it was planted, it had 5. First week became 5 into 2, 10. Next week second week became 5 into 2 into 2, which is 20. Third week became 5 into 2 into 2 into 2, which is 40. So we are seeing that with every week passing by, it's getting multiplied by 2. First week 5, 10, 20, 40. So every week it's getting multiplied by 2. So second one seems to be the right answer. But let's look at the third one. The plant was planted 2 weeks ago. Plant was planted 2 weeks ago. From where that interpretation is derived? There's nothing here, right? It is just a blind guess. So you will rule out this one also. So here, apart from solving this problem, there's one more technique that we came across, which is called elimination. When you're dealing with multiple choice questions, you don't necessarily have to solve the problem always. We have not done any fancy calculation here. We just wrapped our head around the information we had from the question. Okay, this is the function which tells how many leaves it will have after it is planted, based on every week passing by. So t is nothing but the week. So what is the meaning of 2? This 2 is not saying that okay, you had 2 leaves. It's not saying that it was planted 2 weeks ago. It just says that every week, every increase of t is multiplying by 2. If you had 3 here, that would have meant that every week it's multiplying by 3. If you had 4 here, it would have been like every week it's getting multiplied by 4. So you have that many 4 times more leaves than the previous week. That's what it means. So that is how this became our pick from an answer point of view. So let me stop here. Tell me if I was able to make enough sense to you guys. Were you able to follow what I was trying to do? And if you come across a question like this, will you be able to solve it by yourself? Yeah? Rehan, Dhanushri, everybody? Praneet?
Yes, sir.
Okay. So, I made a small mistake. Just give me 10 seconds. I'll be back in 10 seconds. Exactly. So what happens is when you are lost in maths, you become kind of little absent-minded. I filled my water bottle, I forgot to put the straw, and I was struggling to get water from it. Okay, so that's why I had to rush to get the water. But on a serious note, is everybody able to follow what we are doing so far? Dave, Rehan, Sarah, Neil, Praneet, everybody? Okay.
Yes, sir.
Chris? Both the Chris are very quiet today. I'm hoping you guys are not finding it boring so far.
No, sir.
Okay. Alright. So everything remains the same. I mean, questions will change. Our personality will not. So our method for solving the problem will also not change. Tram will always remain in our head. Let's go to the third problem. Let me read it for you guys. It says, a ball is shot into the air from the edge of a building. Okay. So it's always a good idea to keep drawing things, okay? I mean, keep doing scratch work. Even if your drawing skill is as great as mine. I mean, you know what greatness means with respect to my drawing skills. A ball is shot into the air from the edge of a building. So this is the building, this is the edge. Ball is shot from this edge of the building. 50 feet above the ground, meaning saying the edge of the building is 50 feet above the ground. So this is ground and ball is shot from this place. Its initial velocity is 20 feet per second. So when the ball is shot from here, right, somebody like you, me or anybody is kicking the ball and the initial velocity is 20 feet per second. Okay. The equation H equal to minus 16t square plus 20t plus 50 can be used to model the height of the ball after t seconds. About how long does it take for the ball to hit the ground? So, since I have drawn it, I have done the scratch work, I have not tried solving it, I have not jumped to Nike even if I like this brand so much. I have not gone to that place. I am still reading the question. A ball is shot into the air from the edge of a building 50 feet above the ground. Okay. Its initial velocity is 20 feet per second. Okay. The equation H equal to minus 16t squared plus 20t plus 50 can be used to model the height of the ball after 3 seconds. So when you are talking about the height of the ball, you are essentially talking about how far it is from the ground. So this equation is the model for determining the height of the ball after 3 seconds. About how long does it take for the ball to hit the ground? How long does it take for the ball to hit the ground? So we have read the question enough. Look at this. It says there is a building 50 feet tall and from this edge the ball is shot with the initial velocity of 20 feet per second. And this equation tells you what will be the height of the ball after 3 seconds. And it's asking us to find out about how long it will take for the ball to hit the ground. Here, when you read the question so many times, you must be grappling with the fact that what exactly this 20 feet per second is doing. This is just an additional information. If you think too much about it, see, for me to find out the height of the ball after 3 seconds, this information is enough. Where do I fit in the velocity thing? It is just an extra information. And it might not help us with the calculation in this situation. And that will be able to determine when you read this question a couple of times and then you realize that, oh, even if I read it 5 times, I am seeing that this is not playing a role in determining the height of the ball. Okay, that seems to be the case. Maybe somebody who was giving the question was trying to say, okay, fine, it's not falling under the force of gravity. When you hit the ball with 20 feet per second or 50 feet per second or 80 feet per second speed from this place, it will take longer to hit the ground. Maybe that's the reason why they have given this information. But that has no role to play when it comes to determining the height of the ball or determining the time that it will take for hitting the ground. Okay, that's just a back-end information. Is that making sense so far? So now, when we have read the question enough, we know that, okay, fine. When will it hit the ground? Meaning, the height is going to be 0. Okay? This height will be 0. Or, there's one more critical information here. You are hitting it from this height already. So when it hits the ground, see, when you kick the ball, it goes in a path and lands somewhere. Here, when you're talking about this situation, you're talking about the height of the ball for touching the, okay. Do we have to even think about this height? No. It just says, this is the formula, okay? Now, one thing that you would want to think, okay, what happens when no time has elapsed? Meaning, when time is 0. What is the height? When time is 0, it's minus 16 into 0 is squared plus 20 into 0 is 0 plus 50. Oh, this fits in this formula. Before, I mean, when there's no time that has elapsed, the height of the ball is, this is 0, this is 0. The height of the ball is 50. So yeah, everything is fitting based on the information we have. We don't really have to struggle with that. See, I had a little bit of confusion. I was thinking that do I have to find out h as 0 or h equal to minus 50, meaning traveling this distance also. No, but when I substituted t equals 0 in this equation, I see that when it's 0, it's already saying the height is 50, meaning we don't really have to do any fancy calculation around that. This is the most generic formula that we can think of. Now, the question is, when will it hit the ground? Meaning, when will the height be equal to 0? Are you guys with me so far? You saw your teacher getting a little confused, and I was actually simulating that for you guys because you will also think it the same way, right? That do I have to calculate minus 50 or do I have to calculate 0? And when we substituted t equals to 0, meaning before the ball was hit, it was at a height of 50 feet. That is what the question also says. So there is nothing to not really worry about. I'll use this as a generic formula and then solve it. So when will this hit the ground? Meaning when will h be equal to 0? Let's find out. 16t square plus 20t plus 50. Or when we have to solve it for t in this equation. Or we can say minus 16t square plus 20t plus 50 equals 0. This is when Nike kicks in. You have done all your calculation, all your analysis, you have done all your scratch work, and you are very clear what you're going to do. There is no confusion that you will come across now. So that is when you go to your end part of the track, and then you will go solving it. So I don't like to start with a negative, so I'll multiply everything with a minus 1, and here also with minus 1. So I'll minus 1, multiply this with minus 1, and this side also minus 1. This becomes minus into minus plus 16t squared, minus into plus minus 20t minus 15 equals 0 into minus 1. Doesn't make any sense. That is just 0. So we have to solve it for this one. Now there is one more thing that we have learned as part of quadratic equation, that we have to always look at ways to make it simpler. And here you clearly see that you can make it a little easier to look. You can find out the equivalent equivalent quadratic equation from this one by taking 2 out. It becomes 8t squared minus 10t minus 25. So I can take this out, and this is equivalent to this equation now. Just that our calculation will be a little simpler than before. Now from this, same thing, ax squared plus bx plus c standard form. So I will just substitute here minus b plus minus b squared minus 4ac. And when you are dealing with this kind of thing, this is a discriminant. So first thing you would want to do is find out the value of discriminant, because then your calculation becomes much easier. So let's find out the b square minus 4ac value. So b square is 10 square is 100 minus 4ac, 4 into a into c, which is minus 25. So this becomes 100 minus into minus plus 4 into 8, 32 into 25 is 800. 800. So this becomes 900. So your d is nothing, discriminant is square root of this, I square root of this becomes 30. So you got two values of it, x or t. This is not x, this is t. So t you got as minus b is minus into minus 10 plus minus this value, which is 30 divided by 2a. Your a is 8, that is 2 into 8, 16. So you got 2 times, 2 values here. So this becomes minus into minus plus 10 plus minus 30 by 16. So there are 2 situations when the ball will hit the ground at 2 times. So it is 10 plus 30 is 40 by 16, and second is 10 minus 30 becomes minus 20 by 16. Okay. So we have two possible times when the ball will hit the ground. Okay, one is 40 by 16, so it's like 10 by 4, which is 2.5 seconds, and minus 20 by 16, which is minus 5 by 4, or minus 1.25. Now we have come to a very interesting point. We looked at this equation, substituted the value of h as 0 and solved it for t. We got two values, one is 2.5 seconds and one is minus 1.25 seconds. What would be our answer? We have two values of t. Will it be 2.5 and minus 1.25, or it will be only one of the two, or what is your thought process? And I'm trying to pick your brain, okay? Trust me. I'm wanting each and every child in this class to think. And I'm not going to pick up the third question. I want to hear your opinion. Yes, Praneet.
It would be only one of them, 2.5 seconds, because if you have a negative time, that means this is before the ball was shot. We're trying to find out when the ball will touch the ground after you have shot it, so it would be 2.5 seconds.
Exactly. So now when we're talking about after how much time to touch the ground, minus 1.5 is talking about past. Nobody knows where the ball was. It was probably lying in my house, or Deep's house, or Chris's house, or Dhanushri's house. Doesn't matter. We are talking about all the calculation after the ball was shot. So negative time elapsed doesn't make any sense here. So there will be questions where it will confuse you by giving two answers. And if you just go by the mathematical approach for solving it, you'll get two answers and you'll end up picking both of them. Or you might get confused, okay. Or if it says, okay, these are two options, only one option. You'll say, okay, yeah, two options. I solved it. Mathematically it says this is what it is. That is when you think about it, you will not go wrong. And trust me, in the SAT exam, every question that we solve, it matters. Wrong answers don't give us any brownie points. It's only the right ones that matters the most. So it's okay to have only 8 right answers than having 10 wrong answers. Yeah? Are you guys with me so far? So Aditya and Ananya, you guys have joined 10 minutes early. You can join after 10 minutes, otherwise you will end up learning something which is way too complicated for you guys, okay?
Okay.
Yeah? Okay. Alright. So again, I know it might sound stupid, but is everybody with me? And Deep, unfortunately I'll keep on putting you on the spot today.
That's okay.
Are you able to follow? Yeah.
Yeah, I'm able to follow it. I'm understanding it really
Okay. Yeah. And see, this is something that I do purposefully. When somebody joins the class, when it is a first or second class for anybody, I just keep on asking that child more. The reason being, everybody else has heard me so many times. They probably have matched their wavelength with my way of speaking also, right? Which might not be the case with the new kids. That's why I'm asking you guys. I'm asking Deep more. And don't get offended. I'm not trying to put you on the spot by any means, okay? Alright. So Rehan, you have not said anything, but are you with me so far? Are you able to follow what I'm doing here? Okay. Now we have 10 more minutes. Let's try having fun with one more problem, and this time I will not solve it. I would want you guys to give it a shot, and let me read it for you guys. So pay attention to what I say for next 2 minutes. Okay. After a special medicine is introduced into a petri dish full of bacteria. After a special medicine is introduced into a petri dish full of bacteria, the number of bacteria remaining in the dish decreases rapidly. Okay? So I'm just reading the first line one more time, just to see if there's something important for us to know. After a special medicine is introduced into a petri dish full of bacteria, the number of bacteria remaining in the dish decreases rapidly. So, okay, so there was a dish which had a lot of bacteria. So as soon as you introduce the medicine into that dish, the number of bacteria starts decreasing rapidly. Now, how rapidly? That's what we'll see in the second part of the question. The relationship between the elapsed time t in seconds and the number of bacteria in the petri dish is modeled by the following function. So now relationship. So say when you introduce the medicine, the number of bacteria in the dish decreases rapidly. How rapidly? That's what is coming in this model that I'm going to write on the board. And the equation says Nt, that is the number of bacteria after certain time, is following this function: 1000 multiplied by 1 by 2 to the power t by 5.5. Complete the following sentence about the half-life of the bacteria culture. Okay, so now let me read this. First line of the sentence was saying that okay, you have a dish and it is full of bacteria. When you introduce a medicine into this, the number of bacteria in the dish decreases rapidly. And this is the formula which says, this is a model which says how much it will decrease by with every second is a function of this. So when you say after 0 seconds, as soon as you put the medicine, how much it decreased by. So you'll put t equals to 0, 0 by 5.5 will be 0. So it becomes 1000 into 1 by 2 to the power 0 by 5.5, that is 0. Anything to the power 0 is nothing but 1. So as soon as you put the medicine in the plate or the dish, it decreases by this count, 1000. After 1 second, then this formula will come into picture. This question says the number of bacteria is halved. So complete the following sentence about the half-life of the bacteria culture. When you talk about half-life, half-life is nothing but half-life. Come on. You can sit down. Let me finish this class, then we'll talk. So half-life of anything means the time that it takes for the count or the size of the substance to become half. Okay, so that's what is half-life, which you guys would have learned in chemistry, which we are not going to focus on. But conceptually, it's saying, okay, what is, knowing this model, how much time it will take for the bacteria, number of bacteria in the plate to become half. We saw that as soon as you introduce the medicine, it reduces by this many. Half-life meaning how much time you will have to spend for the bacteria count to become half of the whole count. So, if I read the question for you guys one more time, it is just asking us to complete this sentence, which says the number of bacteria is halved every how many seconds? It becomes half after how many seconds? Now, any thoughts? I will, okay, let me read the question one more time. I'll take a break for 2 minutes. I'll let you guys grapple with this problem, and then I would want to hear your opinion on this question, okay? It simply says that in a dish, when you introduce a medicine, the number of bacteria starts decreasing rapidly, and this is the model that you are being given, okay? It says, complete the following sentence about the half-life of the bacteria culture, meaning, when will this become half? The number of bacteria is halved every how many seconds? So I want you guys to think and tell me what would be your interpretation from this one. I'll come back to you guys in 2 minutes, okay? Think about it and then let me know. And the kids who are joining a little early for the next class, level 1 kids, we have 5 more minutes, so bear with me for 5 more minutes, okay? So I want you all to think about it and tell me after how many seconds the bacteria count is becoming half, okay? Think about it and let me know. Yes, sir.
Hello, sir. Mohit. Okay. His name is Rudraksh.
Okay.
Yeah, so he's
Sure.
Actually, my wife would have
Yeah,
been talking to
yeah.
तो ये रुद्राक्ष ये लीडरशिप में पढ़ता है.
Okay.
लीडरशिप प्रेपरेटरी स्कूल चार्टर स्कूल है फिर फ्रिस्को में.
Okay.
हम लोग फ्रिस्को में रहते हैं.
बिल्कुल.
थोड़ा वही अपना जो इंडियन बच्चों का प्रॉब्लम है मैथ से तो बस नहीं तो बेसिकली मैं भी घर में थोड़ा पढ़ाने की कोशिश करता हूँ, लेकिन what I'm seeing is the way we have been taught and these people are teaching in their schools is like fraction, जैसे fraction पढ़ाते हैं हम, हमारे यहाँ पे मतलब different तरीके से होता है, right? ये bond तरीके से बताना है, right? तो ठीक है, अभी कैसे how will it go through, you just let me know.
अभी तो देखते हैं क्लास में, थोड़ा देखते हैं उसको मजा आता है कि क्लास में।
नहीं वो तो मालूम है।
ओके,
1 घंटे में आओ।
हाँ,
ठीक है, चेक। आपका नाम क्या है सर?
Biren.
वीरेंद्र, ओके।
All right. So any thoughts? Yeah, Praneeth. You guys sit down. Your class has not started yet. I'm still dealing with the elder ones, okay? And some of the kids I would want you guys to sit here also, front row as well. Okay. So yeah, Praneeth.
So we the 1/2, if we need to make it half of the amount we have, we have to make the exponent to 1/2 1. So we can multiply 1,000 by 1/2. To do that, we need 5.5 as your seconds.
Exactly.
So 5.5 divided by 5.5 equals 1.
Yeah.
Leaving you with 1,000 times 1/2, which gives you 500 halves.
Exactly. And see, this question looks very complicated on its own look, okay? When you look at this question alone, you will think that, oh, first of all, how do I deal with this kind of thing? But the question is very simple. It's saying, okay, when will it become 1/2? And you have this 1/2 right in front of you. And to get this 1/2, you need to make it 1. That is how this will become 1/2. And how will this become 1? By putting this as 5.5. So the answer would be very straightforward. You did not have to do any calculation, you have to just think about it. So SAT exam also, if you see, you will not be always required to solve the problems. You have to understand what exactly is expected out of you, and then how do you approach it. So that is why my most boring concept, this will, trust me, help you in a big time, in a big way. If your analysis is thorough, see, I don't think Praneeth did any calculation. Did you do any calculation, Praneeth?
No, sir.
No. So this was not even needed. So there will be questions where you don't really have to do any calculation. That's why jumping on to solve a problem in the first go is not the best approach. Now today, this approach got proven right. You could solve a problem, you could get the accurate answer without even solving it. So that is why it is important. Yep. With that being said, I will let you guys go. Enjoy the rest of your evening, and we will meet again tomorrow same time. Whoever has planned for Holi, go enjoy, have fun, have sweets, and we'll meet tomorrow. Yep.
Thank you, sir.
All right. Thanks everybody. All right.
Bye, sir.
Yep. Bye bye.